Okay, today we're looking at Module 4, Lesson 11, titled Factoring Expressions. So we just practiced factors with our sprints. We've actually looked at factors earlier in the year. Back in Module 2, we did some factors. So that's actually going to get married. There are old factoring lessons. We're going to marry it with our expressions lesson from yesterday and see if we can combine the two lessons into one. So let's go past the sprints that we just did. Now let's look at example 1 in your student packet. What is that? How would you represent that? Okay, so here I have 2 groups of 5 and 2 groups of 3. So how many 5s are in the model? How many 5s do you see? 2. This isn't a trick question. How many 3s do you see? 2, exactly. So what does the expression represent in words? So what does it look like that we have here? Tell me in words. Oh no, that's like an expression. I want real words. So I have 2 groups of 5, and what could I see for and 2 groups of 3. What are they? They're all together. When we're combining them together, what would that be?
Like 2 groups of 5 plus 2 groups
Plus.
of 3.
And what operation is plus? Or adding? Addition. What's the answer? That's what I meant to say. What do we call that? It is the, after we add them together, it's called the, what's your answer called in addition? Sum. So this is a picture that shows the sum of 2 groups of 5 and 2 groups of 3. So that's a model that shows the sum. It shows the total. It shows what happens when we add together 2 groups of 5 and 2 groups of 3. Right? That's what that is. So now instead of words, I want an expression. How can I write that as an expression? 10 plus 6. I don't see a 10 here or a 6. You are putting them in the least amount of symbols like yesterday. But right now I just want an expression that represents what I see in this model.
2 times 5 plus 2 times 3.
All right, 2 times 5 plus 2 times 3. I took that and I added it to that. Any questions on where she got that from? Okay. Now, I think some of your notes, or all of your notes, may have a different model than this one. If your model does not look like that, in the middle of page 42, cross it out and draw that model. This model shows 5 plus 3 and 5 plus 3. So this one is showing 2 groups of 5 plus 3. So draw that now in your notes. Because the picture you have in your notes is the same picture from the first example, from A. Is there anybody that has that picture already in there?
Yeah, it is different. We looked at it.
Huh.
But this is different. I mean, more.
Right.
I'll correct it one.
Yeah. I have a headache. All right, so now how many 5s are in the model? Yeah, we still have 2 5s, they're just in different places. How many 3s are in the model? You want to have a thing going on right now. Okay, yeah, exactly. 2 groups of 3. Just like in the first model, they're just rearranged a little differently. So how could we represent this using words? What's happening here and here? What do we have?
5 plus 3.
I do have 5 plus 3, but how many groups of 5 plus 3 do I have? How many groups of 5 plus 3? 2, exactly. So this is two groups of the sum of 5 and 3. You don't have your notes written down. We're already down here. And you don't have these written in either. So what expression could we write? Why break a good thing? Oh, go ahead.
5 plus 3 equals 5 plus 3.
So we have one group of 5 plus 3, and we're adding it to another group of 5 plus 3. But since I have, did you want to say something different?
I have a question. How can you tell multiplication or addition?
Well, remember that multiplication is repeated addition. So here I have the same thing being repeated twice. So instead of writing this as repeated addition, what's another way that I could write this? I have two groups of 5 plus 3. So it's two groups of 5 times 3. Remember, that's what multiplication is, repeated addition. Two groups of, so it's 2 times what that group is. But we don't have to write the times because we know that parentheses means multiplication. So we don't have to say times times. So we just drop the X or the dot because parentheses means multiplication.
For the one that says 5 plus 3 plus 5 plus 3, why did you put parentheses there? Because it's all the same.
Because I'm showing my two groups. You really don't, because I have a group here and I have a group here because of how they were bracketed off in the model. Okay?
Can we do exponents?
Why can't I do exponents? So you want to do this? Is that what you want to do? What would that mean if I did an exponent? Because that does not equal that. Those are not the same. How come I use the 2 outside the parentheses instead of a 2 as an exponent? Exponents are repeated multiplication. So if it was 5 plus 3 times 5 plus 3, then it would have been squared. But those two sums are not being multiplied. Those two sums are being added. So addition means multiplication, not an exponent. Great question, Ashley. Good that we could review that. So now let's take a look at these two models side by side, okay, on the board. So the first model was 2 times 2 groups of 5 plus 2 groups of 3. The second model was 2 groups of 5 plus 3. Are those two models equivalent? Do they represent the same value? How do we know they represent the same value? Exactly, yes. Both expressions have 2 5s and 2 3s. Both expressions, you're writing this down in your notes. Okay, for C on the top of the page. Yes, both expressions have 2 5s and 2 3s. So they're just rearranged a little bit. Now wait a second. I just want to compare these. I have 2 times 5 plus 2 times 3 equals 2 times 5 plus 3. Can anybody make a claim or a statement or a conclusion when you look at this and look at this and think back to maybe something we did earlier in the year. What do you see that both of these have in common? What do both of those have in common? 2 groups of 5 and 2 groups of 3. 2 groups of 5 and 2 groups of 3. What do they both have in common? 2 groups of 5 and 2 groups of 3. What do they both have in common? Everybody? The 2. They both have 2 groups. Do I have to keep writing the 2? Or can I just factor out that 2 and see that I'm left with a 5 and a 3? Which is what that is. We're going to keep practicing that because this is the focus of our lesson today. Taking a common factor. The 2 was a factor here, and the 2 was a factor here. So both of those expressions had a common factor, so I was able to pull that common factor out. You'll see. We'll go through some more practice. What is this called, this property? You're probably used to seeing it this way. Because the parentheses means to multiply, 2 times 5 is 2 times 5. 2 times 3 is 2 times 3. What is that called when we're giving it out to everybody? What is that property called? Distributive property. So in your notes, that's the answer for E. All right, now instead of using 5s and 3s, let's try it with variables, okay? So the first model, we have 2A plus 2B. 2 groups of A and 2 groups of B. So how many A's are in the expression? How many A's are in the expression? 2. Whoops. And how many B's are in the model? 2. We're just going to jump around this part a little bit, okay? So what expression could we write to represent that? What do we have? How can I write that with an expression? What's this half? What do I have there? And then I have added on 2 groups of B. That's what the model shows. A, B, B. 2 groups of A plus 2 groups of B. Anybody not sure where these letters or numbers are coming from, or these expressions? What about this second model? Now I have AB, AB. Instead of A, B, B in the first one, now I have AB, AB. How many A's do I have? I still have, and I still have 2 B's. So what do I have now? What's my expression? I have a group of A plus B, and I have a group of A plus B. So how can I write that as an expression? Jen? Right, 2 parentheses, A plus B. And are they equivalent? Yes, they're equivalent. What do you notice here? What do both of these terms have in common? What do both of these terms have in common, everybody? A 2. So can I factor out that 2 and put it here? And then what am I left with? A plus B. A plus B. They both mean the same thing. We're just writing them using fewer symbols. Pulling out that greatest common factor. Let's practice some more. Let's take a look at example 3, number 1. I have 3f plus 3g. The directions ask us to use the GCF and the distributive properties to write equivalent expressions. We're not solving anything, we're just writing equivalent expressions. So what's a common factor? Because that's 3 times f plus 3 times g. Remember that factors are the numbers being multiplied together. So what's a common factor in that and that? What's a common factor? Everybody? 3. That's a common factor is 3. So I could factor out my 3, and then what am I left with? F plus G. And that's all you have to do. So we expanded it out to 3 times F plus 3 times G. The GCF was 3, and then we factored out that 3 to write the new equation. 6x plus 9y. So 6 times x plus 9 times y. We expanded it. What's the greatest common factor? Is 6 or 9 the greatest common factor? No, we have to find something that they have in common. 3. So you don't have to write this, but I'm just going to picture 3 times 2, and that's 3 times 3. So I'm going to take out that 3. So 3, if I pull the 3 out of the 6, what's the other factor that's left? 2, and then I have the x. Bring down the plus. If I factor a 3 out of 9, what's the other factor? 3 times 3, and I still have my y. So that's the answer for number 2. Let's try the next one. 3c plus 11c. Well, I'm going to expand it. 3 times c plus 11 times c. Now I can see all my factors. What's the common factor in both of those? No, there's something else they have in common. C. So I'm going to factor out a c. So that leaves me with 3 plus 11. You can factor out your variable. Let's jump to the exercises on the next page. 7x plus 7y. We don't have to expand it out, do we? We can see what that is. So in 7 times x plus 7 times y, what's the common factor? 7. So if I factored out the 7, I'm left with x plus y. 15g plus 20h. What do they have in common? What's a common factor? Now you know why we did these sprints today. 5. 5 times what is 15? 5 times what gave me 15? 3g plus 5 times what is 20? 4h. Because I pulled out the factor of 5. So what's the other factor? 5 times what other factor would give me that number? 18m plus 42n. I'm going to go a little quicker now because I want to make sure we get to the next part of the lesson. 6, 3m plus 7n. D. What do they have in common? What do they both have in common? 3. So 10a plus 13b. What does E have in common? F. So F times 11 plus 15. H, 18 plus 13. What about G? What's my common factor for G? 11. But let's be careful now. That leaves me with 5m Should I do plus something? Leave it blank? Drop it off altogether? 11 times what is going to give me 11? What's my other factor in 11 times something equals 11? 1. So we have to put plus 1 there. Because if we left it blank, when we distribute the 11, we wouldn't be distributing it to anything, and it wouldn't have the same value. The same with h. Our common factor is 7. So it's 1 plus 8y. Questions on any of those? Okay. 6x plus 21y. If we were going to factor that out, what would it look like? What could I factor out of that? Well, 6 doesn't go into 21. 3. So this would be 2x plus 7y. But that's exactly what they have written over here. So what they want us to do is to replace the variables with a value, and let's see if they are equal. Let's see if factoring that out changes the value, if it has the same value. So I apologize, I'm going to go very quickly, so stay with me. I'm going to replace x with 3 and y with 7. So 6 times 3 plus 21 times 7, 18 plus, oh, that should be a 4, I'm sorry, plus 84, add them together, 102. Order of operations, I just plug them in and follow out of order of operations. Here, 3 times 2 times 3 plus 7 times 4. I replace the x and I replace the y. 3 times 6 plus 28. 3 times 34. 102. So when I had it written as two terms, or when I wrote it as the GCF and the distributive property, did it change the value? No, they're both equal. So these expressions are equal. So here, if I factored out my G, 5 plus 7, that's this expression here. So if I replace G with 6, hold on, let's see if it works. 5 times 6 plus 7 times 6, 30 plus 42. You should be writing your notes down. 6 times 5 plus 7, 6 times 13, 72. That didn't work out right. That's 12, that's why. Okay, and I'm rushing. So they both have the same value. Good job, have a good night. See you tomorrow. Bye.